Hello, welcome to Chapter 1 of the ECG course, the electrocardiograph. Let's talk about that word for a second, electrocardiograph. Well, let's break it down. Electro, as in electricity, okay, so we're talking about electricity. Cardio, as in heart, and then we have graph, as in, graphic or graphical image. So if you break down that word, it actually tells you what we're talking about. It's a graphical image of the heart's electrical activity. It's exactly what electrocardiograph or an electrocardiogram is. And we use the abbreviation ECG. Now, what is EKG? I've heard that before, right? So ECG versus EKG. Well, I'll tell you, EKG comes from the Deutsch spelling electrocardiogram. And the reason being is because Wilhelm Einthoven, the inventor of the EKG, is from Germany. So EKG was the abbreviation used, and it kind of carried over into the States because we have other things that use the abbreviation ECG. So when you're talking about an EKG specifically, a lot of times it makes it easier to just use the abbreviation EKG. But depending on what you read, you'll see both abbreviations used. It doesn't make much of a difference. But now you have a little bit better of an understanding of why they use both abbreviations. So let's go ahead and get started. Here's a piece of EKG paper. You've probably seen this before, and obviously there's no EKG printed on it. Well, looking at this paper, you'll notice that it is a grid system. And what I want you to notice is that you have bold lines, and then you have the not so bold lines, the smaller lines in red. And those dotted lines, there's 5 boxes going from right to left. Let me change my color here so you can see. From right to left, there should be 5 boxes, and also if you go up, there's 5 boxes. So it's 5 by 5. There should be 25 boxes in each of the bigger boxes. You'll also see these marks up top here, and I'll tell you what those mean in a few seconds. So breaking this down, I'm going to kind of maximize or enlarge one of those bold line boxes. Okay, so one of the larger boxes. So again, you see that you have the smaller boxes. You have 5 going across, and you have 5 going up. All right, it's important to understand that each box is 1 millimeter by 1 millimeter. Each of these small boxes here is 1 millimeter by 1 millimeter. All right, and if you're talking about time, because remember, whenever you're looking at this EKG paper from left to right, you're talking about time. And that's because it's being printed, and if we're talking about in the US, it's being printed at 25 millimeters per second. And I believe in Europe, it's 50 millimeters per second. And that print speed kind of can tell us the time, looking at this paper from left to right, how much time is being passed. So if that's confusing you, we'll kind of look at it here. One of these small boxes is 0.04 seconds. Take a look at what this is telling us. 0.04 seconds, which is the same as saying 40 milliseconds. All right, so if we multiply that by 5, if we have 5 of those small boxes for one big box, you have 0.20 seconds or 200 milliseconds. And that's going to become very important when we start interpreting EKGs, because the time, the intervals for so many different complexes is very important. And actually, we could tell the patient's heart rate based on this grid system, using it to determine time alone. All right, so from left to right, we're talking about time. A small box is 0.04 seconds or 40 milliseconds, and the larger box, these big boxes that we have one maximized, is 0.20 seconds or 200 milliseconds. Now, if you're going up and down, you're talking about voltage, okay? And it's important to remember that 2 large boxes is 1 millivolt. That's what this information over here is telling us. 2 large boxes is 1 millivolt going up. All right, and usually your machine, your monitor, will calibrate that. All right, looking at these lines again on the top that we were talking about before, I said I'd come back to, those are your 1-second lines. All right, because each large box is 0.20 seconds, each one of these large boxes is 0.20 seconds. 5 of them, if you multiply 0.2 times 5, you get 1, is 1 second. All right, so 5 large boxes is 1 second. So this is a 3-second piece of paper that we got here, because you can note that there's 15 large boxes. If you count these from left to right, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is a 3-second piece of paper. And again, it's going to become very important. When you're interpreting EKG rhythms, a 6-second strip is often used to identify the rhythm. All right, so let's use a 6-second strip. And let's identify the heart rate here. Now, I don't have an actual EKG on here. We're just going to use these stars and pretend that the stars are the complexes that we're counting. So if we count the stars here, let's say that each one of these stars represents a heartbeat. All right, we've got 1, 2, 3, 4, 5. We have 6 stars total. Okay, so let's write that number down here, 6. Now, how long is this EKG strip? Well, if we count it out, we've got 1, 2, 3, 4, 5, 6 seconds. All right, because remember, each one of these spaces is use that information to identify the heart rate. Since we have a 6-second strip, we know that 6 seconds times 10 equals 60 seconds, or 1 minute. And we want our heart rate in beats per minute. So we have 6 beats here. We have 6 beats. And we want to get that, how many beats per minute, right? So 6 beats, all we have to do again is multiply by 10, because we have a 6-second strip. So 6 beats times 10 equals 60 beats per minute. And that's just a very simple way to quickly get a rough estimate of the heart rate. It's not exact, and I'm going to go over different methods to identify the heart rate as we go. So let's take a look at a faster one and a slower one. So on this top one, all right, how many stars do we have? Let's start with the whole star. Let's not count the half star yet. We have 1, 2, 3, 4, that's a 4, 5, 6, 7, 8, 9, and I have a half star at the end and a half star at the beginning, so we could say we have 10 if we add those together. All right, we have 10 stars, and again, we have a 6-second strip. 1, 2, 3, 4, 5, 6-second strip. So we could take that 10, multiply it by 10. Remember, you're going to multiply by 10 because you have a 6-second strip, and if you want to know how many beats per minute, you would multiply by 10. So 10 times 10 is 100. So this top one is about 100 beats per minute. All right, now looking at the bottom one here, how many stars do we have? Well, we have 1, 2, 3. We have 3.5. So 3.5 is 3.5. 3.5 times 10, because again it is a 6-second strip, is going to give us 35 beats per minute. So this bottom one is 35 beats per minute. All right, so that's kind of a simple way to do it. And both of these are very regular rhythms. All right, very regular rhythms. And depending on, the regularity or irregularity, your heart rate may vary. And let's take a look at a couple examples of irregular rhythms. All right, so we have an irregular rhythm on the top and a regular rhythm on the bottom. Let's first do the rate of the rhythm on top. All right, so again, we're going to start with the whole star here. We have 1, 2, 3, 4, 5, 6. And again, I have a half star at the end and a half star at the beginning. So if we added those together, we would have 7. All right, 7, and it is a 6-second strip. 7 times 10 is 70. All right. So this method, this 6-second strip method, is pretty good if you're looking at an irregular rhythm. It works out pretty good because it's going to give you an average. If we try to use a different method that we're going to learn later on, you might not be as accurate with irregular rhythms. Let's look at the bottom one. We have a 1, 2, 3, 4, 5, 6. We have 7 stars also in the bottom, and that also gives us a heart rate of 70. So even though these two EKG rhythms look very different, and I know they're not actual rhythms, we're looking at stars here, but kind of use your imagination. They look very different, but they both have the same exact heart rate. Okay, and again, it's a rough estimate because of the method we're using. So that's it for chapter 1 on the EKG graph. And in the next chapter, we're going to start getting into the different EKG leads. And it's going to be very interesting. So go ahead and click chapter 2 if you're ready for that. And don't forget to subscribe to our channel. Thank you, and please leave comments below.